Okay, I will just start introducing myself. My name is Kristensen. I took over the CEO position in Strusoft from August this year. I have a background as a structural engineer. And I actually, when I was working as a structural engineer, I was a customer at Strusoft also. So I also know Strusoft from the customer point of view. So I think it was 7 years ago I opened Strusoft in Denmark. And now I've taken over the Strusoft AB, the global Strusoft business. I have a lot of experience in educating at different universities in structural engineering specifically, which is my topic. So I will keep it short, and now we'll jump to the most important thing. As you all know, we have a lot of different products in Strusoft. We have our big calculation programs. We have the smaller calculation programs, and we have the impact. We are really good in those areas as boxes. So what we are now searching to find a solution on is how to interact the information between the boxes. So this is one of the topics I will present here for you today. A traditional workflow, this was from a Danish consultant called Niras. Traditional workflow coming from a Revit model, which is from the architect sent to the structural engineer. The structural engineer sets up all the analytical walls, deciding which walls are load bearing and which walls are not. Taking it over to FEM design to put on the loads from the wind, from the snow, and calculating all the forces down to the soil, to the foundation. We do that really good in FEM design. And we can control how the forces go down here. So the next step is, we can also see the results in forces in each wall, how many kilonewtons acts on the walls, and we can get an overview how the model reacts, behaves. So this is a traditional workflow. We see all the forces in between the joints, like this, and you can model your joints according to that. So, first I would like to ask you all a question. When you're in the production team, you're sitting with impact, and you get some material from the structural engineer. How often is that material sufficient to design your elements? Have anybody of you discovered insufficient material from a structural engineer? Please raise your hands. Okay, some of you have. I cannot mention one project I have heard of when the structural engineer sends in the structural report and the precast factory not coming back to them and say, we missed this and this and this. Always a lot of stuff is missing. And then the structural engineer is frustrated. They come to me and they say, okay, but what do we need to deliver? So that's a great question. Let's go ask the factories. Can you give us a draft, how you would like it to look? No, 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 no. It's up to the designer. It should just be sufficient. So it's like nobody really want to decide what's enough. So I took on that mission. And this is what this presentation is about. How transferring data between the consultant and the factory. So it's really, really time consuming as it is today. And also, does it have the right information and format? So to quote John Lennon, imagine. So I told the programmers, imagine that we could generate easy, readable documentation to the factory from the consultant. Imagine that we could do a standard for how it should look like, so everybody knows. And imagine after finishing your FEM design model, you click one button, and everything is done automatically. Couldn't that be amazing? Okay? So what we have done, the prefab print output module automatically sets up the whole report you need for all your wall lines. It's simple to read, and it's easy to check all your stresses, sliding, stability, and anchorage results. That was the mission. An output where table results are adapted to the viewport automatically, so you don't have to set up paper sizes or anything, it's done automatically. And a viewer where the factory can open the model and easily see the results for each wall. This was the dream. And I came with this one slide to the programmer and said, can you do this? Because the programmers love one thing. If you give them a challenge, they will solve it. This was the challenge. So they started. I had these also. I just wanted it to be really simple. One page for one wall line. I would be able to see, I need to see the stresses. I need to see in one picture, I need to see the forces, and I need to see the reaction forces on the bottom. I need to see the forces in between the walls, in the shear joints. One place, one page. That was the dream. And I need to follow it from floor 4 down to floor 3, floor 2. Simple, easy, understandable. Where does the forces go? That was the task. So with a little bit of inspiration from some of our other programs, you might recognize a little bit if you use the project manager. We was a little inspired by that. This model is actually coming from FEM design. I will show it live after how it works. It has some of the similar functions as we see in the impact. We have height and all these stuff. What happens here is that you go into the information, you put your project details, you select if you want linear elastic or you want plastic calculation reports. Then you click the print and you click the print. This will take 30 minutes. I'll not click the print. I've prepared a little. And then you get something out like this. It's a bit complicated model with many load combinations, but it shows you it automatically sets up all the measurements. No measurements in FEM design anymore. It's automatically generated. Every measurement automated. Everything is live here, so you can click on the loads and you can see what is this load, 6 kilonewton, okay. You can see all the loads, everything is alive in the PDF. And you can follow your results all the way down. Let me show you a live, real example. Before I do that, I have to tell you that this version I'm going to present to you live now, I got it yesterday evening. I asked the programmer, because it's a beta version, is it stable enough? Yeah, he thinks so. Then he texted me before I went on, but you tested it, right? No, but you can follow the presentation via the link on YouTube. I will do that, he said. So we will see. So this output module needs to be open. I open my FEM design and I just made a really simple project here. It has some anchors and it has some walls. It has a little bit of loads, a little dead load, a little wind load. And the wind load just been added as a line load, horizontal line load. And what I do, I go and I run the analysis. So now it has to run through 60,000 equations. All right, something's happening. Okay, and this is actually a fun story. We asked the programmers, why do you spend time showing the time for the calculation? We just want to move on. Yeah, but we compete with the other software vendors. Programmers are amazing people. So they don't remove it. This is the reason it's there. Over in my prefab print, I now have the message, a new calculation has been made in FEM design of another building. Do you want to load that building? Yes, I want to load that building. Let's see where it went. And now it looks like this. I can choose what load combination I want to print. And I would like to have it plastic. I can put the name if I like. I can, of course, display the model. It's just like this. And I go to my print setting. And this model I've done, the wall model, is typical from a structural engineering point of view. No measurements or anything. No measurements. So what the program does now, it goes into the engine of the FEM design program and takes all the geometry out. And then it measures everything. It takes all the qualities, the quantities from the concrete. It takes all the forces. It takes everything that you actually need in the factory to design. In Denmark, it's often like this, that the structural engineers are calculating all the forces and passing those information on to the factory, because the factory would like to design their own elements in-house to be able to save a little bit of reinforcement. And it's this gap we're trying to close. But this can also be used for the factory internally, because it's different people who does the different things. So right now, it's please be aware, it's a beta version. I didn't want to do a video about it, so we will have to wait a little until it have set it all up. Beta versions. Yeah. I confronted him with this, and they said, yeah, but we estimated this time based on a modern computer. And it is 7 years old, so maybe I should upgrade some. But it feels more than a minute. Okay. Now I have the open PDF possibility here, and I get a little bit of overview. But if we scroll down, I see it automatically sets up all the stories like this. I can see the model, how it looks. And if I go down, if I zoom out a little, I can see we're now at 15 meters height. We have the fifth story. And the geometry, as you see, is automatically adapted to all holes, openings. It also have the vertical measurements as well. Everything is, as I said, clickable. So you'll be able to see, okay, how long is the load, what is the total load, what is the line load. So everything is in here, and you can print it if you like. We also, of course, have the tables, if somebody wants to do that. And you can easily follow the load all the way down here. So if we go to the story below, let's go to the bottom, that's the worst one. It's like this. So now we have forces here of 4,000 kilonewtons per meter. It's a total load of 1,500 kilonewtons. And of course, from this, we also need to have some checks. And if I go to have the compression check, everything is live in here. I can see, okay, how many megapascal is the compression compared to the load carrying capacity. How is it with sliding? Do I need sliding reinforcement? And how much should that be? So everything is calculated in this system. So really, really, really simple. This was, for us, the first step. The grand idea of this is to see if we can somehow connect this to the project manager someday. To be able to click on the wall and see all the structural analysis done behind that wall. Connect the things. It could be amazing. So this is where we are now. Okay? I hope it's something you can use. I think it's really amazing. Okay, thank you.